So we know impulse is equal to mass into change in velocity, which is final velocity minus initial velocity. Now, with respect to this given problem here, what is final velocity? It is velocity after impact. So the ball is dropped, it impacts on the floor, and then it changes its direction. So velocity before impact, BI, is the initial velocity. The final velocity is velocity after impact. Okay. Now we do understand what impulse is. The question here is, could this question be done using concepts that are not in the chapter of laws of motion alone, rather from other chapters such as motion in a plane, motion in a straight line, or work energy path. Okay, right. So pause the solution here, think of it, and if you can come with any other concept to solve this, let's have a discussion on that as well. So we will, I think, we will go through this question in four different perspectives. Watching, trying to solve the same solution using four different ways. Four or three? I think it's three, and then one more discussion on the on the rebound itself. Yeah, I think three and one. Okay, so this is one. For the motion along AB. Okay, let us also visualize what happens here one more time, just to make sure that we understand things very clearly. So okay. So a spherical body of mass 100 gram is dropped from a height of 10 meters. So this is 10 meter. 100 grams is the weight of this object. It is dropped. After hitting the ground, it hits the ground. The body rebounds. The body rebounds to a height of 5 meter. So the key points here are 10 meter, 5 meter, and of course, what is the mass? The mass is 100 gram or 0.1 kilogram, and initial direction of motion after impact, final direction of motion. It reverses. So if this is plus V, this becomes minus V. Okay, that's better to say. If we consider this motion direction of motion to be negative, then the final direction of motion is positive. Okay, reversal in direction of motion. Now, keeping that in mind, for the motion along AB, for the motion along AB, which means motion along the object being dropped till before hitting the ground. So A, B. We know the height is given to be 10 meter, so S is 10 meters. The initial direction of motion is like this, acting downwards. Acceleration due to gravity is also acting downwards. Since both of them are in the same direction, we take acceleration, we take the value of acceleration to be positive. And since the acceleration is due to gravitation, this becomes acceleration due to gravity, which is plus 10, right? And since this object is dropped from rest, the initial velocity, u, will be velocity at A being dropped from rest, the initial velocity, which is velocity at A, will be equal to 0. The final velocity, which is velocity at B, will be, just to make sure that we get the idea clear, we'll write velocity at B as velocity at B before impact. Okay, velocity at B before impact. Why? Because the ball is dropped from A, it comes like this, and then it traces its path back. So it is the same point that it is hitting and the same point that it travels back. So we need 2 points. One is BI and BF for our clarity. Okay. So acceleration is G 9.8 times 10. 2 times 10 is 20 times 9.8 is 196. And therefore VBI is root of 196, which is 14 meter per second. Okay. Now for the motion along BC. What would motion along BC stand for? After impact till reaching a height of 5 meter from B to C. The final velocity is VC. Initial velocity is velocity at initial point, which is P, VB. Acceleration is minus G. Why? Let us see. So this is initial direction of motion. Acceleration of due to gravity is acting in the opposite direction. Since acceleration due to gravity is opposing the velocity of motion, acceleration due to gravity would be taken as minus 10, right? Minus 10. So 2 into minus g, oh, my bad, not minus 10, it would be minus g instead, right? Minus g. So 2 into minus g is 2 into minus 9.8 into 5. Now, what about VC? The object, when it comes to the maximum height 5, the velocity at this point, VC, is going to be equal to 0. Why? Because at 5 meter, this ball is momentarily at rest, and therefore velocity at C has to be equal to 0. If Vc is equal to 0, this term vanishes. Therefore, we have minus Vb square is equal to 2 into minus 9.8 into 5. Negative by negative is positive. 5 times 2 is 10. 10 times 9.8 is 98. So we have Vb is equal to root of 98. Oh, yes, exactly. What else can we add here? For better clarity, we can write this as B final, velocity at B after impact, right? Velocity at B. What did B follow there? After impact and before impact. So this is before impact, and this would be velocity at B after impact. Velocity at B after impact. Okay. Or maybe we can consider velocity at B after impact as the final velocity. Right? Now, let us write down what we have found out so far. So we found out that velocity at B before impact is 14 meter per second, or I can write velocity initial is 14 meter per second. And what is velocity final? Velocity final is velocity final, which is velocity at B, is velocity at B is 10 meter per second. Now, okay, let me just take you through one more point here. See, while we say this is velocity, there is something very important that we're missing here. We have already neglected the direction because this calculation here is done with respect to the magnitude. So the direction is lost in this calculation. Or else, if we were to maintain direction as well, then this complete equation has to be written in the vector form, which is something we haven't done. So this is scalar representation, which means these velocities have to be very specifically mentioned as scalars. So what I will choose is a reference axis, according to which going downwards says negative and going upwards says positive. So since velocity before impact is going downwards like this, just so since velocity before impact is going, oops, since this is going Okay. Since the velocity before impact is going downwards in this direction, it is going downwards. I will take this as negative. And since velocity after impact is going upwards, I will take this as positive, which will give me velocity final as positive and velocity initial as negative. One more time, velocity initial as negative and velocity final as positive. Now we have on collision at B, direction of velocity reverses. So velocity B is acting downwards, it reverses, and velocity of B is acting upwards now. I hope this point is clear, right? Now, once we have this, what is the formula for impact? Mass into change in velocity, which is final velocity minus initial velocity. Final velocity is velocity at P after impact and velocity at B before impact. Final velocity at B after impact is 10 minus 14, which is, well, see, this actually should not be rounded as 10, given the fact that we are solving for JE mains, and at times the accuracy has to be up to one decimal point or maybe one significant figure. So I shouldn't be doing that, but just for the sake of solving it here, I've done that. Please make sure that if the question demands a numerical type input question, then please follow significant figures or the decimal point, whichever is given. Okay, so I have assumed nine. I mean, I've rounded off 9.8 as 10. Now, velocity final is plus 10. Velocity initial is minus 14 here. Minus minus 14 is plus 14. 10 plus 14 is 24. 24 times mass, which is zero point 0.1 kilogram, is 2.4 kilogram meter per second, which gives us the impulse. Okay, so that's one way of looking at this. Coming back to from where we started, we said that this particular question can be solved using many ways. It can be solved using the, the equations of motion, which is what we did now. This can also be solved using work energy power, work energy. Oh, I'm sorry. What was I saying? I was saying the mechanical energy conservation theorem, and can also be solved using mechanical energy conservation and using work energy theorem. So we did one, and we'll discuss these two in detail: conservation of mechanical energy and work energy theorem.